Hey there, Doug from TauStats. In this series of videos, I'm doing an overview of the Bittensor network and how it functions. And so far in this series, we've talked about subnets and we've talked about the participants of the subnets. And in this video, I want to go a little bit deeper and talk about just what miners do inside the subnets. And so with that, let's just get started. We'll kick off just at the big picture. Bittensor is a really large intertwined network, and the biggest way to divide it up is into the different subnets. And today, the day I'm recording this video, there are 52 subnets. About a year ago, there was one. So this is changing over time. Each subnet has a specific task. There's inference subnets, there's storage subnets, etc., etc. One way to think about this in an analogy to the real world is a shopping mall or a high street, where each subnet is a different store. You could have a couple inference subnets, just like you might have two clothing stores on the same street. For the analogy that I'm using here, I'm assuming that we've got a shop that sells violins. From the subnet perspective, you've got a subnet run by a subnet owner, and inside each subnet, you've got miners, the folks who do the work, and you've got validators, the people who analyze the work and check it to make sure that the work the miners are doing meets the requirements of the subnet. If you want to talk tokenomics, 18% of all of the emissions to the subnet goes to the subnet owner, and 41% is split amongst all the miners, and 41% is split amongst all of the validators. Using this violin shop analogy, the miners are the folks who are making the violins. If you're selling violins, the miners are creating violins, and the validators are out in the front of the shop greeting the people who come into the shop and selling them violins. They're also looking at all the violins that are being made and grading them. This is a really nice violin. It's going to cost $10,000. This is a nice violin. It's $1,000. Here's a $50 one for your kid who's just learning how to play the violin. So we've got all these miners in the back of our violin shop, and they're making violins. What they need to do is follow the rules of the subnet. And the subnet is going to create the rules of what makes a good violin, right? If it's a pre-training, here are the rules on the training. Here's what you need to do, and then the miners are doing some training. The validators are then grading those violins and deciding which ones are the best violins and which are the worst violins. And this is shown inside TauStats. You can look on the metagraph for the subnet, and here I've sorted the metagraph by incentive. All of the miners are graded by the validators. The validators create a score, and then there's a thing called UMA consensus that combines all of those scores and gives the consensus score to the validators. This is then turned into an incentive. If there's 200 and some miners, the incentive across all of the miners adds up to 1. So I sort of think of it as a percentage. And so this incentive score tells the miner how well they're doing, but also how much tau they'll receive when there's a distribution event. That correlates into the emission, which we can see here. And then we can multiply that out and figure out approximately how much tau each miner will receive every single day. Another graph that we have in TauStats is that it's the incentive across all of the different miners. And so what can we see here? What this is telling us is that the miners up over here are doing a great job. They're making the best violins. They're providing the best results for that subnet. We've got a bunch here that are, above average. We have a lot here that are in the middle. And then this dotted line is the miner with the lowest incentive score. And that's important because mining is very competitive. If a new miner comes in and wants to sign up for this subnet, the miner with the lowest score gets kicked out. Just like if you're running a shop and you've got high-performing employees and low-performing employees, if a new person comes in, you might lay off the low-performing employee and bring on a new employee. So mining is incredibly competitive because you want to do better than all the other miners because you want to end up over here. But you also don't want to end up down here at the bottom because you get kicked off. You'll notice that there are a lot of these orange miners as well. Those are miners that have just registered and they have immunity. So you're given an amount of time where you can practice making violins and get graded on it. And if you're making nice violins, you stay in. And if you are struggling, you'll stay down here at the bottom and get kicked off. You can actually see here that there is a miner with immunity who's doing really, really well. Like the analogy would be they're making really nice violins right off from the start. You hired somebody with 20 years experience, they came in and they're doing great. Another thing we can do inside TauStats is we can look via the cold key at all of the different miners that a specific cold key is running. So for example, this cold key has 15 neurons, different miners running across 10 hotkeys. And it was across a couple different subnets, but we can see that they're running at least 4 miners here on subnet 4. That's just where I cut off the screenshot so it would fit. And so the analogy here is you're really good at making violins, clone yourself and make 2 violins. Because it's not a great analogy because we're doing this all with compute. So if you've got a model that's working really well, you could spin up a clone of that model and have 2 miners running on the same subnet. So we have all these miners across this distribution of miners. And assuming everyone's playing by the rules, this is all good. Things are great. But there'll be times where a miner finds a loophole. And let's talk through a couple of those loopholes and how subnet owners work to prevent that from happening. One of them is an idea called relay mining. So in relay mining, we've got a miner here who's making violins. And a request comes in and the validator assigns it to this miner to make a violin. But rather than making the violin himself, he goes and makes a request to a validator and says, hey, make a violin for me. And miner number 2 makes the violin. It gets returned back, gets graded by the validator, returned to him, and then he returns it to the validator and it comes out delivered. So what ends up happening here is that 2 miners are doing the work. Well, 1 miner is doing the work, 1 miner is not doing any work at all, and only 1 result is emitted. A lot of subnets put timing as one of the grading factors here because obviously this miner created the violin super quick. This guy was a lot slower because he had to take possession of it and then deliver it. There are other ways to prevent relay mining, but this is one thing that miners do to cheat. Another thing a miner might do to cheat is to really examine the rules inside the subnet, right? And if there are loopholes, maybe they can take advantage of those loopholes until they get fixed. So in a really rough example, what if the rules were in this violin making subnet, the violins have to be XYZ dimensions and they have to weigh a certain amount. And this miner realized that he could just make some origami violins and put some lead shot in the bottom so it would hit the weight and be the right dimensions. And he could still receive emissions, right? It would pass the validation and he would be graded as a pretty good miner. Maybe not the best miner, but enough that he can stay in the subnet, but he's not doing any work. That's great and all until the subnet starts getting bad reviews, right? If you're a customer and you order a violin and you don't get a violin, you're going to leave a 0-star review. That damages the subnet. So the subnet's going to change the rules and you as a miner are going to get kicked out until you start actually making violins again. Another question I'm frequently asked from people who are thinking about mining is, where should I start? How do I start mining inside Bittensor? And there's no real good answer here, but you have to do a little bit of research. And as you can see here, this is a screenshot of the 52 subnets as they exist on the day I'm recording this video. It could very possibly change by tomorrow. But you have to look at all these different subnets and see if there's anything here that might be interesting to you. We can also look at some stats that might help you make your decision. On the subnets page at TauStats, you can see a list of all of the subnets. And one factor that I see a lot of people interested in is the amount of emission. Subnet 19 gets almost 8% of all the emission. Like, that would be a good place to go because there's a lot of tau being distributed from that subnet. However, that subnet's been around for like 10 months. So some of the miners on that subnet have been doing this for a really long time. It's probably pretty unlikely that if you took the default miner from subnet 19, that you could be anywhere competitive against the folks who've been doing this for a real long time. Like, you're going to have to do a lot of trial and error to catch up to the folks who are actually succeeding in this subnet. If we resort this table and we look at when the subnets were registered, we have a lot of subnets that are just a couple days or a couple of weeks old. Now, you'll see that the emission isn't great here, but the thing is all of the miners are just learning how to operate on this subnet. So there's no head start from the miners who have been in the subnet for 10 months or 12 months. You're all about on an equal playing field. So if you come in and are successful in this subnet, and the subnet eventually starts getting emission, you can be successful and be a successful miner on those subnets. And then in a year, you'll be one of those people who's been in this subnet for a real long time and being successful with it. So you could look at some of these subnets and say, maybe I'll try one of these. Each of the subnets is open source, and a lot of them list the compute that's required. Be careful. Sometimes these are out of date, but this is a screenshot from a subnet that doesn't require a GPU, so it might be a little cheaper to run a miner on this subnet. And then finally, look at the subnets and see if there's anything interesting to you. Like if you're a biologist, you might know that this is a protein structure. Maybe you'd be interested in the protein folding subnet. It's a subnet that's helping scientists figure out the structure of different proteins. Like that's kind of cool if you're a biologist. But there's a huge list here. I would recommend going through there, doing a bunch of research and seeing what, gets your interest. Because each subnet is very competitive, you're going to be spending a lot of time working with the code and how it works. So it would help if it's something that you're really interested in as well. So with that, thanks for watching. TauStats is the analytics engine for the Bittensor network. And then all of the AI generated images here were created with Corcel out of subnet 19. So you can try that out at corcel.io and build your own AI generated images and play around with our LLMs. Both TauStats and Corcel have fully fledged APIs, so you can build whatever you want with them. Thanks for watching, and keep to this playlist to find more videos about how the Bittensor ecosystem works.